Hello, I'm Michael Wybrow, and in this video I'm going to give an introduction to iOS, which is the operating system that runs on iPhone and other devices and that we'll be using in the unit. So, iOS is an operating system that runs various types of Apple's mobile devices, certainly the iPhone and the iPad, and previously the iPod Touch when that device existed. For those that don't know, iPod Touch, kind of an iPhone without the phone communication features. And iOS was first introduced with the iPhone, which was in 2007, and it was based on OS 10, OS X, which is now known as macOS. So it was specifically designed for mobile devices, but based on a real desktop operating system, and then just with all of the touch-based interfaces on top of it. More recently, the version of iOS that ran on iPad devices has been split off, and it now includes different multitasking and multiple app features, but also support for pointers, so like using trackpads, for example, which iPhone doesn't have. Vision OS is the operating system for Apple Vision Pro. Again, it's similar but has some of its own unique features, and you'll see examples where things can sort of be used across these operating systems. To give you some idea of the size of the platform, and I try and update these for each delivery of the unit. So there's currently more than 2.29, almost 2.3 million iOS applications available. This is in the App Store, and this was early this year in March, this number came from. The App Store paid developers around $23 billion. This is United States dollars. And this was from app revenue last year. There's more than 4 billion apps that the App Store distributes each day. And obviously this is multiple downloads of apps onto different devices, which is why these numbers are as high as they are. And there's around 2.35 billion active iOS devices as of June this year. This is a number that Apple frequently talks about on their earnings calls. And this just gives you a size of the market, how many potential users are there of your devices. And one point to note as well is that iOS apps, the system architecture is ARM, and Apple in the last few years have migrated their desktops from being Intel-based to now using their own chip architecture, which is what they call Apple Silicon, and that means that iOS apps now can also natively run on macOS. So there's a couple of levels to iOS. There's a layered architecture with 4 layers. At the base is the core OS, and this is much lower level, and then you have a services layer above this and a media layer, and on top of this Cocoa Touch, which is the higher level. And these the lower you go, the closer you get to lower level programming languages like C, and the libraries and frameworks that you use are much closer to the hardware. And the higher you go, they're much more abstractive, and they use object-oriented programming, and things are all in Swift, and you can use them very easily. The Cocoa Touch layer describes things like multitasking, or handles, I should say, multitasking, touch-based input, push notifications, high-level system services. And we'll be working with a number of things like UIKit we'll cover throughout the unit. MapKit is something we cover in week 6 or 7. And there's other things like GameKit and EventKit that a part of Cocoa Touch. Below this, there's a media layer, and this is working with graphics and audio, also handles things like AirPlay, where you have media streaming. And some of the frameworks here are things like AVKit and AV Foundation, Audiovisual Foundation, and Core Graphics. We'll use some Core Graphics features just to show some image transformation and manipulation in the unit. We'll also make use of some things that are part of AVKit to show you how to work with some audiovisual features. Below this, there's some core services, and these are system services, things like phone access, data management, iCloud, in-app purchases. We'll make use of a couple of these. Core data is used for persistence of data, core location for getting access to various sensors that talk about where the device is, both like GPS, and then motion gives information about where the phone is in space and what its movement is. And then at a very low level, there's things like core Bluetooth and system security. And as I mentioned before, these are very low level. Often they're C-based frameworks, as in the C programming language. And you can deal with things like sockets and threads and working with external accessories. We're not really going to cover much of that in the unit. So Xcode is the integrated development environment. It's a free download on Macs. It's not available on Windows or Linux. So if you have your own Mac, you're welcome to use it and download it and use your own computer is what I mean. If you don't have a Mac, that's completely fine. Many students who don't have a Mac do the unit. We have Mac labs on campus that you can use. Your lab classes are held in these Mac labs, and you have access to the Mac labs outside of your lab time. And there's typically one lab that's mostly not used for classes, I think, except Friday morning this semester. So you can make use of that. So Xcode includes an code editor. It includes debugging features. There's a interface builder for constructing UI. It includes simulators for iOS, and you can download simulators for different iOS versions. It has built-in help, and it also has deployment tools. And the latest version that we'll be using is Xcode 16.3 or 16.4. And this is targeting the current latest version of iOS, which is iOS 18. It is worth noting that what would be iOS 19, but is going to be called iOS 26, will be released probably around September, so during this semester. And that also means there's beta versions of new versions of Xcode and iOS that are available already. I have used these. I frequently use these betas as part of my own development. I do not use them for the unit. They're very, very buggy until they get to a release version, and they cause lots of problems. And it's very hard to tell if the problem is with Xcode or some part of the iOS toolchain, or is a real bug in your app. I mean, they're provided to developers so they can file problems and report issues before the next version of iOS is released, but we don't want to use them in the unit. Having said that, there are some changes to iOS this year, and we as a teaching team are aware of that, and we will talk to you about what some of those are, because I'm sure some of you will be interested in those and our opinion of them. So Swift is the programming language that we use in the unit. It first appeared about 10 years ago now, in 2014. Its current stable release is 6.2. This is the version that's available in the current version of Xcode. And it was written specifically for macOS and iOS. There was a prior language that Apple created, which was a sort of superset of C called Objective-C. And when they created Swift, they designed it to be both a faster, safer, and more concise version. And they've said that they really designed this to be a teaching language, but also to be able to do systems or server programming. So really a great language for all of these things. The syntax of Swift is like C, kind of in C++. It's based off languages like C# and Objective-C, but there's some key differences. So we'll cover those in the unit. And it also has some features of its own that are unique to Swift. Okay, thanks for watching.